Hi everyone, welcome to another video in Chat Physics Live. Today I'm going to be talking to you about numeracy skills in physics and how we can support our students to understand the way in which equations work. So the first thing I'd like to talk about today is identifying quantities from a question. I find it really important to consider the difference between quantities and units with students because we represent both quantities and units by shortened versions, just one or two letters, and I don't like the idea of them getting them confused. So let's think about the quantities first. I want to take this question. Calculate the weight of a 2 kilogram penguin if the gravitational field strength is about 10 newtons per kilogram. Now, firstly, what I would ask students to do is to break the question up into pieces to identify those quantities before we move forwards. So first things first, reading the very first part here, calculate the weight. And it's quite good practice to get students to annotate on their documents, whether that's by underlining, circling or highlighting. Now this says calculate the weight. So the first thing I would do is write down W for weight. They could write it in words if they forget the symbols in which we represent these quantities. It wouldn't hurt at all. And I'm going to put here a question mark. So the weight equals don't know. And that indicates to me that that's what I'm trying to find. That's what I'm trying to calculate, which is really useful for when we have to rearrange equations. It next says of a 2 kilogram penguin. Now it doesn't specify here the quantity that we are using, but what we can do is to identify the unit. This is mass, because we should know, hopefully plenty of recall practice, that kilograms are the unit for measuring mass. And we represent mass by a little m, lowercase m, and that is equal to 2. Now here, some people are inclined to write the units. Now, the way I explain this to the students is that if I'm confident that the unit is correct for putting it into an equation, in other words, we want to put mass into kilograms for an equation so that we get the correct scale of value out, then I actually don't write the units here at all. And that might go against what you consider to be appropriate, but I find that it stops us worrying too much about what we need to do with those units, because if they are the correct units, we actually don't need them again. And I'll talk later on about when they may be useful. But if our question here instead said a 2,000 gram penguin, then I would encourage students to write mass equals 2,000 grams and convert straight away. So what this does is it gets the students to think, okay, I'm not happy with this unit here, to sub it into an equation, so I'm going to convert immediately and put an appropriate value into the equation, because I don't have to worry about then dealing with it later when it's part of another equation. Now lastly, it says the gravitational field strength is about 10. So I'm using quite simple values here just to get the point across. So gravitational field strength is about 10. I'm happy with my units, so I'm not going to worry too much about them. Now, hopefully, having had plenty of practice, we can identify the equation as W equals mg. And sometimes right at the beginning of learning, I say to the students out loud, weight equals mass times gravity. If they're unfamiliar with not putting a multiplication symbol there, that might really help them later on. Now it's time to substitute, so I'm going to substitute first. It's quite good practice because if students struggle with rearranging, then by substituting numbers in first, they can often reduce the amount of quantities that we actually have. That can be really useful. So first of all, we look at weight. Well, we don't know weight. I wouldn't encourage students to write a question mark here though, because once we get to the end, ideally we need to keep an eye on what it was we were finding so that we remember to put the correct units in. So I encourage them to keep this as W. We've got our equals, our mass in the correct units is 2. Now don't forget, when our two quantities here are next to each other, we are indicating a multiplication, and G is going in here as 10. And we can find that that is equal to 20. And because we found weight, hopefully we know that weight can be referred to as a force. So I'm going to pop capital N in there for newtons. So this is an example of how we can clearly break up parts of a question to find the quantities that are given, pop them down on our answer with the correct symbol there, and then work the equation from here. Now, next I'd like to talk about rearranging equations, and this is by concrete example. So in other words, something that students are really familiar with, an equation that they understand to be true, that they can use to represent one that they are less confident or familiar with. So this question here says, calculate the current in this circuit. Now, working from what we did before, we would see calculate the current, think about current being I, so I equals, don't know. And then looking at our circuit here, which I've just popped off bite size. And the first value is up here, 6V. Well, if we're working in a unit of capital V, that's volts. So we know it's voltage or potential difference. I often say voltage and then clarify that that could be potential difference. I think at key stage 3 and key stage 4, there's no real reason to make it too complicated there in differentiating between the two. So we know that the voltage is 6. Am I happy with those units? Yes. So I'm not going to write them here. And down here we have 12 ohms. So that must be the resistance. So the resistance equals 12. Am I happy with the resistance being in ohms? Yep, so I'm not going to write that down either. Now, hopefully, somewhere in our memory, we can remember that V equals IR. Now, I can see that when I put these values in, I'm going to rearrange at some point to find the current. So I'm going to have to make I, or current, the subject of this equation. But maybe if I'm starting out, I'm not really entirely sure how to do this. So over on the other side here, I'm going to give you a walkthrough of what I would do with students, particularly those in perhaps year 7, to get them to understand what this equation really means. So the first thing I'll do is I'm going to write an equation in exactly the same format, but with numbers instead of letters. So I'm going to write something that will hopefully be fairly familiar. 15. Then I need an equals. Now I need 2 numbers that multiply together to make 15, to make this an equation. I'm going to go for 3 times 5. Something quite straightforward, nice low numbers there, which they can calculate relatively easily. So what do I do now? Well, this equation on the right is representing the equation on the left. And again, you might just want to confirm that IR really means I times R. You can always pop that in. And we've got 3 times 5 representing this. Now we know that we are trying to calculate the current. So we know we are trying to make I the subject of the equation. Now, if we compare these two, we can see that 3 best represents the position of I. So I'll write this at the front, so make 3 the subject of the equation, and we're representing what we're trying to do in our V equals IR equation. Now, I have 2 numbers left over here, and because this is an equation, I need to do something to these 2 numbers that will give me 3. So I would pose the question to the students and allow them to take this part all by themselves. How can I get 3 using 15 and 5? Honestly, one of the things that they are most likely to say is, oh, multiply. For some strange reason, it tends to be what they always want to do. I think because they seem to be more familiar with multiplication. But if they do, talk them through it. What is 15 times 5? Work through it with them and then say to them, is that equal to 3? And most people say, no, that's not equal to 3. So then you can say, okay, but we need to use 15 and 5 to get 3. So what do we do? And we will get to the stage where they say, okay, we need to do, or we need to divide. Now be very careful there. Which way do we need to divide? we need to do 15 divided by 5. Now we can double check. Is 15 divided by 5 equal to 3? 15 divided by 5 is 3. So yes, we are happy that this rearrangement works to change the subject, and it's still an equation, it's still true. Now what we're going to do is we're going to follow exactly the same process, but with the letters. So we have 15 after the equal sign now, but what did 15 represent up here? Well, start of the equation, so it must have been B. Then I have a divide, so point out that you actually needed a divide, so that's going to go over here now. And finally is 5, that was our last quantity over here, so this is going to be R. So we can double check that, but hopefully students will be confident, maybe with a little bit of practice, maybe repeat a couple of times, that actually we're just rearranging exactly the same way because we are confident that this rearrangement gives us an equation that is true. So now we can pop our numbers in. I, we don't know, so just write I again. V, we said was 6, and R was 12. And now we can see that I is equal to 0.5. Now I've got I here telling me it's current, so I can remember to pop in amps. So that's how I would use a concrete example to help students understand how to rearrange. Now my next example is rearranging by using the units. So sometimes this works really well. This is an example where we're using speed, distance and time, which is quite familiar and quite easy to use. Sometimes the units are more difficult. If we don't have our SI units, it might not really make sense, but let's have a look at where it does. First of all, calculate the speed. Now I'm going to use S to represent speed, nice and simply here, and a question mark for don't know, and it tells me that's what I'm trying to find. If I leave it blank, I might be trying to put in a value there, I might be trying to find one for it, but actually that's what we're trying to calculate. And then it says the speed of a wave that travels 1,350 meters. Now, nowhere does this tell me what this value is for which quantity, but we do notice that it is in meters, so this tells us that it's going to be a distance. I'm going to go right ahead and use D for distance. The distance travelled was 1,350 meters, but I'm happy with the unit. Last one, 5 seconds. Well, it doesn't tell us the quantity, but again, we can find it by looking at the units and saying, well, seconds is the unit we use to measure time, and this is 5. So perhaps we are at the stage where a student says, okay, I've got S, D, and T. Do I know an equation that links the 3? Well, perhaps they know the equation as distance equals speed times time, which is quite likely. And we want to know how to rearrange for speed. So what we're going to do now is we're going to look at the units. So I know that I'm trying to make S the subject, so I'm going to pop S at the start. But I'm not really sure what to do with these other quantities at the minute, and how can I find out? Well, we could think about the units used to measure speed. Now, even if we consider miles per hour, this would work just as well. But meters per second would be even better. Either way, we'll write down a unit for speed and then identify what each one is measuring. Meters measures distance, and seconds measures time, but that's actually a fraction, as we can see from our units over here. So if speed is measured in meters per second, which equates to distance per time, I've actually just rearranged the equation for myself so that I can go ahead and solve the equation over here. So all I've done there is identified the units that are appropriate for speed and pulled out the quantities relevant to that by using the units with the quantities I'm familiar with. Meters is distance, speed is time, so meters per second must have come from distance divided by time. So back over here, we still don't know S, we have 1,350 over 5. And just to finish that off, I guess that is 270. We're calculating speed, meters per second. Thank you for joining us at Chat Physics Live. If you have any questions or comments, you can find me at Miss B 0107 on Twitter.